Hello, this is the Daily Space for today, Monday, October 28th, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Most Mondays through Fridays, either I or my co-host Annie Wilson will be here bringing you a quick rundown of all that is new in space and astronomy. So today is really the absolute most Monday of Mondays. And it is a Monday more so for the Mars Insight team than perhaps for anyone in the field of astronomy. Over the past many months, we've been following the adventures of this self-hammering probe as it tries to bury itself 5 meters beneath the surface of Mars. This weekend, Mars spit the probe out. There's really no other way to describe what happened here. This probe is designed to use friction to hold itself in place while it draws up a weight and then hammers that weight down, theoretically allowing it to hammer itself ever downward. After an initial deployment, it got stuck for several months, and people here on Earth experimented in sandboxes to both replicate the problem and figure out how to solve it. In the most recent trial, it was guessed that the hammer had a mostly hollow area of space around it, and it didn't have enough friction to effectively drive itself downward. To get around this, mission scientists tried putting pressure sideways on the probe using the InSight lander's scoop. This worked temporarily, allowing the probe to descend centimeter by centimeter for a small number of centimeters. And then for reasons that aren't yet known, Mars blew the probe backwards out of its hole. Mission engineers are now trying to figure out if they can safely move InSight's shovel, and they are trying to sort out how to get this probe to do something. I'm not going to lie, I burst out laughing when I saw Twitter user Lars the Wanderer share these images over the weekend. If you were ever to imagine a planet going, "Nope, I will not be probed," this is what that would look like, folks. My heart goes out to everyone working on the Mars InSight thermal probe. People have been waiting for years for this data, and it would not be unusual for there to also be scientists out there whose funding is related to this mission and who won't get their funding until the data is delivered. We can only hope that there's going to be a whole bunch of amazing papers coming out of whatever caused Mars to spit the probe back out, and that these folks will someday be able to laugh at Mars spitting out their probe. All right. So from there, we're going to move on out to other solar system news. The Very Large Telescope in Chile has imaged the Hygeia asteroid. This small rocky object is the 4th largest asteroid behind Ceres, Pallas, and Vesta. And while Pallas and Vesta are both flattened out, not exactly spherical objects, Hygeia appears to be quite round. And in these images obtained with the SPHERE instrument on the Very Large Telescope, they're also not seeing any large craters. This unusual shape makes Hygeia the smallest of the known dwarf planets. To be designated as a dwarf planet, a world needs to be orbiting the sun in a belt of other objects, and it needs to be a sphere. Now, it may be a bit of a fluke of luck that Hygeia appears to be a dwarf planet. Vesta and Pallas, both of those objects have massive basins and appear to be flattened. And since the VLT images have no clear signs of impact basins on Hygeia, it appears this world just simply escaped having any massive collisions that reshaped it the way Vesta and Pallas were probably reshaped. Had we been able to see all three of these objects early on in our solar system's history, we might have classified Vesta and Pallas differently. At this point in time, however, they are not dwarf planets because they are not round. And little Hygeia, measuring just 430 kilometers across, wins the record for being the smallest asteroid by several hundred kilometers. Okay, so our last story of the day is one that is going to absolutely hurt my brain. And before I hurt my brain, I'm going to say thank you to Kevlar for the bits and give Eddie a treat in thanks. Come on. Hi, you're good. Here you go. All right. So apologies, all of you who dislike having dogs during the episode. But sometimes before you break your brain on cosmology, you just give a dog a treat and a cuddle. So our last story of the day, I'm doing last because it's hard. And I know there's going to be a whole lot of questions. And this is a story straight out of theoretical cosmology. And it looks at the first moments of formation of our universe. Now, before I get into the science, I want to start with a disclaimer that neither the English language nor the casual language of scientists are consistent in their usage of some key phrases. In general, when someone says Big Bang, they're referring to the entire process that originated our universe, led to the era of inflation, and carried us through to when we were a hot soup of hydrogen, helium, and trace amounts of lithium and beryllium. Now, while that is how many and maybe even most scientists use the phrase Big Bang, there are those among us who use the word Big Bang only to refer to what happened after the initial epoch of inflation. For them, the universe is formed, the forces split. So when the entire universe initially formed, all the forces were like one big gobbledygook. The forces split. Then there's this crazy time of exponential expansion. That's called the epoch of inflation. And then, and only then, the Big Bang more slowly expands our universe. For the rest of this episode, we are using this narrower definition of Big Bang. Okay, so the reason for this separation is to make it easier to discuss the two different expansions of our universe. The epoch of inflation, while brief, was also mighty and is responsible for giving us the smooth universe. The cosmic microwave background looks pretty much it gives us that smooth background that causes the cosmic microwave background to look pretty much the same in all directions. Now, in a new paper in the journal Physical Review Letters that is not behind a paywall, you can all go read this paper. A team led by Rachel Wing describes a new model that allows the universe to undergo inflation, which would have cooled the universe, and then reheating it to trigger the Big Bang. So let me back that off again. Universe comes into existence. It undergoes massive inflation. Inflation cools things off. It then has to get reheated with the Big Bang expansion coming next. So two different types of expansion, one called inflation, one called the Big Bang, and a period of reheating in between these. So to accomplish this all in one model, she and her team needed to modify gravity to behave differently at very high energies and deviating even from relativistic effects. According to the MIT press release, quantum mechanical effects predict that the strength of gravity can vary in space and time when interacting with ultra-high energy matter, a phenomenon known as non-minimal coupling. This added term was important because it allows the universe in their computer simulations to transition from the rapid inflationary stage to a reheated Big Bang stage. Now, I'm not going to lie, this paper is more than I could fully absorb in time to prepare for the show. It would actually probably take me an entire week of reading related literature to feel I had a good understanding of it. And that is a week of reading time I just don't have. What I can tell you is the folks in this paper have made a universe in a box that is internally consistent in both how the universe comes into existence, how it undergoes the epoch of inflation, how it reheats and then expands out in a way that facilitates Big Bang nucleosynthesis. This model didn't require anything extraordinary beyond the modifications to gravity at the highest of energies. This ability for a model to transition gracefully between the different phases of the universe's expansion is, as far as I know, novel. I don't know when or if we will have the capacity to check this gravitational coupling in high energy environments in a lab. I don't know when we're going to be able to prove this extra term is or isn't correct. While we can simulate some of the energies of the Big Bang, inflation has stayed out of reach. But if this theory is to become accepted, it could drive additional research that, well, uncovers other possible tests of gravity. I, for one, am eager to see what research papers build on these simulations. This is a story that's only beginning, and I look forward to following it for the years to come. And we will be bringing you all the updates that come right here on the Daily Space. And that's all I've got for today. So I hope your brain doesn't hurt quite as badly as mine. And I will now stick around and try to answer your questions. No promises, folks. While you type them in, I'm going to remind you, please precede your questions with that purple circle with a darker purple star in the center. And while you type them in, I'm going to let you know that this is a production of the Planetary Science Institute, and we are produced by Susie Merck, who is back from vacation. We are so glad that she took time off, and we are so glad she is back. This means that everything should be running a little bit more smoothly this week. We are associated with a 501c3. That's what the Planetary Science Institute is. And that means that your bits, your subs, your donations are tax deductible where the law allows. We are here because of you. And if you are out there watching thinking, this is great, all the science is mine, thank you. Please consider giving. And if you don't have it in you to donate, I get it. I totally get it. Please share our show. These are the two things you can do that will really keep us going. Okay, that's all I've got for today. In terms of wall of text, I am now going to find your questions and answer them. Let's see, scrolling up to the top. Yeah, it's so totally a Monday, Veronica Cure. Yes, you exist, Paranor. You do exist. Hello, everyone. I'm just going to say hello, everyone, because there's so many names. 2 steps forward, 2 steps back. Yes, this is how it goes sometimes. So Refs Matt writes, heat flow probes are not easy. On Apollo 16, John Young accidentally kicked the data ribbon connector out of the heat probe and broke it. Oh, God, that's horrifying. Paranor, I'm not sure it farted it out. I'm thinking more a matter of spitting it out. So let's go look at that video again, because really, I can just look at this video all day. It's down, and now it's not. It just gets spit out, sort of like Mars went and just couldn't deal. Yeah, it's kind of awesome. Looking to see what other questions they have. Thank you again, Kevlar, for the bits. Susie Murph comments that Hygeia looks like a golf ball in space. I totally agree. So Veronica Cure asks, is the reheating of the Big Bang similar to the reheating of a frozen burrito? Nothing that tasty. Nothing that tasty. I'm now going to have frozen burritos for lunch. You have made me do it, Veronica Cure. I blame you. I blame you with love. So Henny asks, at what point in the Big Bang did the particles form? Was it just fields before then? It wasn't so much that it was just fields as everything was pure energy, and it was too hot for particles to form. Particles began to form, I think it was, I don't want to lie to you. I think it was after the age of inflation when we started to get particles, and I know Big Bang nucleosynthesis, which is when we started to get things more complicated than just a single proton. That occurred after the age of inflation and before the conclusion of the first 3 minutes. So everything that we talked about today occurred in the first 3 minutes of the universe. Followers are free. It's true. So Henny goes on to ask, when did the matter-antimatter annihilation end? Oh man, I totally don't remember. I'm so sorry. These are things I haven't had to deal with a timeline of this for so long that I just don't remember exactly where in the first 3 minutes all of this occurred. We did a really good episode of Astronomy Cast about this a while back, by which I mean potentially many years ago. So please go check out that episode of Astronomy Cast. So Rigel asks, do we know how quickly the probe was spit out? Yes. Let me look it up. There's timestamps on the images, and I believe that Lars the Wanderer has it in their Twitter feed. Pardon me while I scroll for a minute. Sorry, I'm looking as quickly as I can. I saw him write about it this weekend. It was one of these things where my husband was like, what are you looking at? Because I laughed so hard at the images. So these are all from Sol 325. The first tweet he has is, anyone look at the Sol 325 Insight images yet? Not good at all. And then he shares them. There's one more frame in the sequence. Yeah, I'm not seeing the timestamps on his thread. It was over a very short period of time. I'm not seeing immediately where it was. Let me see if I can find the original images. Yeah, I'm not seeing a time series on it. It was over a matter of just a couple of minutes. Sorry that I couldn't answer that accurately. All the images are up on the internet, so you should be able to find them. So Broken Symmetry asks, how did the real planet paintings end up? Are you referring to the planet painting I did on Saturday? I think everything went well. So Larry is asking, is Hygeia a frost world? Maybe melting is involved in its roundness. It's just an asteroid. It's a regular everyday rocky body. And the natural shape that things will form into, if they have enough gravity, is round. Now, the issue is if you take something round that isn't big enough, when you hit it, it will get deformed, and hydrostatic gravitational pressure can't pull it back into being round. So Vesta probably used to be round, but then got clobbered and flattened and is no longer round, and thus no longer counts as a dwarf planet. So Jane asks, did you hear about the U.S. Air Force testing a space plane, or about Samson sending up weather balloons that look like satellites called Space Selfie as part of a 5G promotion? So I heard about the U.S. Air Force. I did not hear about the Space Selfie. I'm going to have to go find that one. So we usually do updates on rockets and other aircrafts on Wednesdays. That's really Annie's knowledge to turn around a quote she uses. I only know enough about what's going on in launches to be awkward. I'd say be dangerous, but mostly I'm just going to be awkward. So the U.S. Air Force has been testing a space plane for quite some time. It holds the record for the longest anything has gone up and then landed gracefully as it came back down. And over the weekend, there was, I don't even know the right set of words to use anymore. So when you launch things into space, you're supposed to register them so that you don't jeopardize other people's spacecraft. It turns out the U.S. Air Force was using their space plane to deploy other things off of their space plane that they never registered. And this has a lot of people frustrated. I'm just going to leave it at that. I do need to go read about Samson sending up weather balloons that look like satellites. Looking to see. Teal. So Broken Symmetry, the world I painted that was teal came out excellent. Yes, those I'll post pictures later. So Annie will be live at 10 p.m. Eastern. Launch is scheduled for around 11:30 Eastern. So there will be more this evening. Hello, quantum computing at MIT. We actually were talking about actual computing at MIT earlier in this episode. After 2 and a bit years in orbit, it came back, yeah. So this evening is going to be all the streams, all of them. There is Open Space, which we will be simulcasting here on CosmoQuest. There is a launch, and on my personal Twitch channel, I'm going to be reading Scary Story. So all the things are going on, all of them. But for now, we have the perfect number of users. There are 42, not users, viewers. There are 42 viewers right now, and that's kind of amazing. So Rigel16 is asking times. What are the times for Open Space? 7 Central, which is 8 Eastern, 5. Oh, I'm lying. Okay, it can't be both 7 Central and 9 Eastern. I like the way Binary Blaze is like, I was told 9. Okay, so it's 8. So at 8 Eastern, which is 5 Pacific, is going to be open space at math is hard at 9:30 Eastern, which is 6:30 Pacific. I will be reading scary stories on Starstrider, and we have launch at 10 p.m. Eastern. I don't know if I'm launching, if I'm time zoning everything correctly. Oh, I love our chat. Lunch is 11:30 p.m. Easternish. Okay, so you guys can manage to see everything because I go offline at 10 p.m. Eastern. So I will raid CosmoQuest when I'm done reading. And so much good Twitch. That is true. That is very true. Okay. Oh no. Bill comments, I had my scope configured for the wrong time zone this weekend, and it took me longer than it should have to figure that out. That's just horrifying. Horrifying. I'm sorry, Bill. I am so very sorry. Time zones are hard. I'm not sure they're your friend. You did get a good image of Orion Nebula, though. That's a good thing. That's a very good thing. Okay, so I am now going to go record the podcast version of the show. And I'm going to work on making sure I have things better set up for tomorrow because, wow, today was all the technological fail. But I think we're slowly figuring everything out. So thank you all so much for being here. And yeah, that's all I've got. Enjoy your Halloween week, and we will be here bringing you the science most Mondays through Fridays, including Halloween Day. That just makes me so happy. Thank you. So tonight will be all the streaming, all of it. And use your emotes, use them freely for all the things. And I'm going to now go record the podcast version of the show. I'm going to eat some frozen burritos. I'm sorry for the timeout triggered by Nightbots for all of the awesome use of emotes you've Tvin. Sometimes our Nightbot is a little insane. Sorry, Larry, Nightbot lost its mind. We love all of you, even if Nightbot is sometimes mean. We'll be back tomorrow. And yeah, thank you all for being here. And use all of the emotes, but in multiple comments. And wherever you are in the world, have a fabulous morning, evening, or afternoon. Bye-bye.